Good afternoon to all. So today we are going to discuss about the theories of failures. The theories of failures. Okay, so the theories of failures are for static loading, not the dynamic. What is that? Static load. Okay. Another thing is there the dynamic load also there, but that for that purpose we can use the Soderberg, Gerber and Goodman methods. Okay. This is another criteria and this is a different one. Okay. So first of all, let me tell you what is the failure. Failure. Okay. What is failure? The failure it may be the failure is it may be the sometimes break into two parts, but sometimes it won't be. Like that, suppose the failure of the component is, there is a stress strain diagram. Okay, this is typical diagram for mild strain. This is a strain, this is strain, and this is a stress. Okay, so you can see here there is a proportionality limit is there. There is a yield point, upper yield point, lower yield point, ultimate stress and fracture point. Okay. So in the ductile material, failure is not here the fracture. If comes here, there is a plastic deformation. So once the material will get deformed, it won't regain its original shape. So it can't do its proper function. So you can say the failure. So theories of failures. Theories of failures. There are total 5 theories of failures are there. The 5 scientists who derived these theories of failures. First of all, let me tell you why theories of failures comes into picture. Why theories of failures comes into picture. Okay? Look at here. Suppose this is the shaft. Okay? Assume this is the shaft. Okay? Now I am applying the tensile load. When I apply the tensile load, you can't see the shaft, you can see the rod. It is a rod. Okay? So what are the stresses induced in these what are the stresses induced in these? The tensile stresses. If you apply the tensile load, the stresses will be the tensile stress. Okay? This is the axis of the rod. Suppose the same rod if I bend like this. Bend. Look at here, I am bending this rod or shaft whatever like this. I am bending. So what are the stresses induced in this? What are the stresses? Sigma B, bending stresses. Here, sigma T, tensile stresses. Suppose the load is compressive stress, then the compressive stresses will be induced. Now coming to the shaft, take one shaft, okay, and apply the torsion load. What is the torque? You have to apply the torque T. Then the stresses induced are shear stresses, torsional shear stresses. Now look at here, this is the very important. If the load is in uniaxial direction, okay, along the axis, maybe along the uniaxial, not biaxial or triaxial, uniaxial. Suppose the tensile load is there, the only load is acting along the axis. Suppose the bending only one load is acting. Suppose the twisting torque, the only uniaxial load is acting in these 3 cases. So we have elementary equation. Okay, what is the elementary equation? Stress is equal to load by area. Okay, suppose the cross section is the circular one, then for the circular one, the pi by 4 is the area. Now it is the P by pi by 4 d square. This is the tensile stress. Okay. So let me tell you what is the stress. What is the stress? Stress is the look at here. When I apply the load like this, P, then internal resistive force will induce. What is that one? Internal resistive force, that is act like this. Like this. Okay. Like this, the internal resistive force will be there. This is the R. Okay. Now, what is the stress is internal resistive force by area. So So that internal resistive force is equal and opposite to the load. So you can say the resistive force is the load applied, load by area. Like this, the stress concept will come. Is K. Okay. Now look at here. For tensile stress, the load by area formula. That is the elementary equation. For bending stress, 32 m by pi dq. This is the elementary equation. It came from the bending equation. That is very, very famous equation. M by I is equals to sigma B by Y is equals to E by R. This is the bending equation. Like that, we have very, very famous equation, that is the torsion equation, that is E by J is equals to tau by R is equals to G theta by M. Okay, these are the very equation, very important equations. From this equation, you got the bending stress and the shear stress 16T by pi dq. Okay, so units are Newton per mm square, Newton per mm square, shear stress also Newton per mm square. So look at here, the load is unidirection. So go to the tensile UTM, universal testing machine. What is the universal testing machine? We take a dog shape, okay, like this, okay. We like this, we will pull like this, we are apply the force. Now the stresses are induced in the tensile stresses, that are unidirection load is active. So you can get the properties like proportionality limit, yield point stress, ultimate stress, fracture stress, etc. Everything you will get, percentage elongation from this universal testing machine. But actual cases, look at here, in the actual machine, is it the unidirection load is acting? No. Is it the only bending is acting on the particular one shaft having in between the gears are there? Okay, suppose this is the shaft, in between there is a gear is there. With torsion load, due to the weight of the gear, the bending also there, bending. So bending stresses also there. So torsion stresses, bending stresses. Sometimes you may see the load is acting along the axis, tensile load, with that bending also be there. With tensile, torsion also be there. The combine also be there. So now the theories of failures give this solution. Okay? So what is the theories of failure? When the shaft, when the component is subjected to unidirection or bidirection stress system. When the component is subjected to unidirection or bidirection stress system, then we have to use the theories of failures. We have 5 theories of failures who derived 5 scientists. What is the name of the scientists? Like Rankine, Guest, von Mises, and Hayes. These are the scientists. So let me tell you one theory. Okay. First theory is the maximum principal stress theory. It is also called Rankine theory. The scientific name is the Rankine theory. Okay? So maximum principal stress theory. The Rankine, it is a scientist. What he did, you know, he taken that data, tensile data, from which UTM machine, universal testing machine. So before understanding of all theories, you remember one stress strain diagram in your brain. Stress strain diagram. So it is very easy if you remember the stress strain diagram. You know it is a proportionality limit up to this, the stress is proportional to strain. Then there is the upper yield point, there is a yield point, lower yield point, ultimate point, etc. Okay? I am not wrote down in here because I will don't have that much of time. Okay? So in detail I will. Right. So now the yield point is there. What is this one? Yield point. Stress at this point is yield point stress. Now all scientists what they did, they taken the data from the simple tension test and they compare their theory with this. How? Look at here. Look at here. The maximum principal stress theory. Okay? maximum principal stress theory states that the failure of the component, the failure of the component, the failure of the component takes place when the component is subjected to complex stress system. Then it fails. It fails when its maximum principal stress theory, maximum principal stress reaches to the stress at yield point. Stress at yield point. Okay? This is the proportionality limit. This is the yield point stress. Okay? Very simple. Look at here. This is the tensile specimen data. Okay? Universal testing machine. So it is having the yield point stress. Okay? What this theory says, the maximum principal stress reaches to the stress at yield point in simple tension test. This is the strain, this is the stress. It is a simple stress data. Okay? So when maximum principal stress reaches to the stress at yield point in simple tension test, then the material will get fail. Then the material will get fail under bidirection or tridirection stress system, or you can say the complex stress system. It means that the load is acting like this, some tensile load and some torsion load, or some bending load like that. The combined loads will be taken. Okay, that is the maximum principal stress theory. I am not writing here. I am okay. Right. Now coming to the second. This theory, look at here, the maximum principal stress theory is denoted with sigma T1, okay, according to R.S. Kurmi, and there are R.S. Bandari also some different notations are there. So what it says, the material will get fail when it will fail sigma y. When yield point stress, maximum principal stress, sigma T1 is the maximum principal stress. Okay, sigma yt is the yield point stress. Yield point stress. So when it reaches to this, the material will get fail. When the specimen under complex stress system. When specimen under complex stress system. Now, if I consider factor of safety, then sigma Ty is equals to sigma Yt by factor of safety. Sigma Yt by factor of safety. This is the first theory. What is the maximum principal stress theory? Okay. Now we will discuss about the second theory. What is that one? Maximum shear stress theory. Maximum shear stress theory. Okay. So maximum shear stress. So it is called Guest theory. What is this one? This is a Guest theory. Scientific name is the Guest theory. Now look at here. Very simple. Okay, remember every time the stress strain diagram. This is the stress strain diagram. There is a yield point. Now look at here, how the definition will be. According to this theory, the maximum shear stress reaches to the shear stress at yield point in simple tension test. Then the material will get failed. Okay? According to this theory, the failure of the component takes place when maximum shear stress reaches to the shear stress at yield point in simple tension test. This is the simple tension test. Okay? So that is thing one. So maximum shear stress is noted like this. The maximum shear stress theory is like this. So the Mohr circle is there. Mohr circle. Do you know Mohr circle like this? This is the tensile stress like this. So according to Mohr circle, the yield point stress, half of the yield point stress. Half of the yield point stress is nothing but the maximum shear stress. Okay, no? So sigma Yt by, if I consider the factor of safety, sigma Yt by factor of safety into 2. Okay, na? So this is the maximum shear stress theory. Like this, the maximum strain theory is there. Later, maximum strain energy theory is there. After that, the maximum distortion energy theory also there. So maximum distortion energy theory is used for solving like ANSYS software is there. So very accurate result you will get, but more iteration will be there. So one Mises stresses we can say in the ANSYS. Okay. So the maximum shear stress theory used for ductile material. Okay. Earlier the maximum principal stress theory it is used for brittle materials. So this is the theories of failures. Okay. So I hope clearly understood. Okay. Thank you, one and all.